Hi everyone, welcome back to our channel. Today we are going to discuss about finding the H parameter for the circuit shown below. So here this is an dependent source. This is very important in competitive exams as well as academic point of view. Very simple to we are going to solve here. So what are the original equations we require? Let's first write down. So this is V1 I1 at input port, output port is V2 I2. You need to express in terms of these two parameters. So V1 I2 is equal to H11 H12 H21 H22 in terms of I1 V2. So V1 is equal to H11 I1 plus H12 V2, and I2 is equal to H21 I1 plus H22 V2. H22 V2. So these are the standard equations we have in our hand. So we need to find these two values. Okay. So some disturbance is there. This is a current source in parallel to an resistor. So here I am going to apply source transformation technique. Now I am redrawing the network. So I have V1, here I have RA, and here I have RB, and here this is an RC, and you can see the current direction is forward direction. Then automatically we are going to get this is positive terminal and negative terminal, and the magnitude is I into R. So that is RC into alpha I1. So this is the voltage, and here you have the voltage which is nothing but V2. The current in this branch is I2. So this is how we transform for a better understanding. We need to link this equation. So an unknown voltage is formed here. Let's try to find out this unknown voltage. So the current in this branch is I1. Let's try to write down the nodal equation at this point. So let's try to mark this current as some Ix. So apply Kirchhoff's current law. So what is entering at node B? So what is entering current? Entering current is I1, leaving current is Ix, and one more entering current is in this direction, which is nothing but I2. So I1 plus I2 are entering, leaving is Ix. So I am going to write down in the standard format. So how to write down I2? So the voltage at this point is V2. So I can write down I2 as plus V2, and current is leaving, or the leaving polarity we have, minus RC into alpha I1 is the one drop, minus, so this is positive terminal, this is negative terminal, the leaving terminal is minus V is the I2 divided by RC value plus what is the I1 value. We don't need to write down I1 value, we require the I1 value. Okay, so this is I1, that is equal to Ix. How to write down Ix? Ix we can write down it as V minus 0 divided by RB. So now we require, so while we are performing here, so what we'll do here is first initially we'll make V2 equal to 0. So when you make v2 equal to 0, these two terms will become 0. So therefore the h11 we are going to get it as v1 by i1. So when you make v2 equal to 0, the next parameter what we are going to get is h21 is nothing but i2 by i1. So next we are going to make i1 as 0. So I1 is equal to 0. When you make I1 is equal to 0, then you are going to get H12 is equal to V1 by V2, and H22 we are going to get it as I2 by V2. So this is the 4 we need to find out. So in this procedure, first what we are going to do is V2 equal to 0, then we are going to find out these two. So that's why I am short circuiting this branch. When I short circuit this branch, then I am going to get, I require the value of V now. So this is nothing but RC will get cancelled. This is nothing but alpha I1 minus V by RC plus I1 is equal to V by RB. So this I am going to write as alpha I1 plus I1 is equal to V by RB plus V by RC. So I require the value of, so this here I can take I1 as common, which is 1 minus alpha, and I'm taking V as common, which is 1 by RB plus 1 by RC. So if you take the LCM, this is RB, RC, and here this term you are going to get RC, and here you are going to get RB, which is I1 into 1 minus alpha. So I require the value of V, the unknown voltage, that is I1 into 1 minus alpha into RB, RC divided by RB plus RC is the required value of V. So why we had done it, we can understand here. So this is the value of V. So now we need to find out this parameter. So at this port only. So I'm going to find out this parameter. So this parameter means I have V1, I have a resistor RA, I have a resistor RB. The voltage what I have been find is V, and the current in this part is I1. So I need a link between V1 and I1. So I'm going to apply the KCL at the input port. So when you apply the KCL at the input port, apply KVL to link all the parameter KVL at input port. So the current is leaving, what is the voltage leaving polarity? V1. So plus V1 minus I1 RA, the voltage is positive, negative here, minus V equal to 0. So now we require the relation between only these V1 and I1. So V1 is equal to I1 RA plus V, but we require H11. How to write down H11? H11 is equal to V1 by I1. So already we have this equation. So divide that equation. How to write down that as I1 RA plus V completely divided by I1. So here you are going to get, when you take it as RA plus V by I1. Okay, so that is equal to R. You see here, H11 should not have any other terms than other than V1, I1, it should be there. Okay, so here we are having V by I1. So this is I1. How to write down V value? So V value we can write down it as I1 into 1 minus alpha RB RC divided by RB plus RC. So I1 will get cancelled. This will be the value of H11, which doesn't have V1 I1. So this is the value of H11. So this how we will find H11. And next we'll require the relationship between I2 and I1. Okay. So in order to do this, let's try to link our equation. So here what we already discussed is, so all this we are performing under the condition V2 equal to 0, meaning is that V2 is short circuited. Okay, so whenever the V2 is short circuited, we require the relation. So still now we have been find H11, and now we have to find out H21. Okay, so the value of H21 we need to find out should be in terms of current again, I1 by I2 I require. Now let us try to find out the expression for I2. So what is the expression for I2? If you redraw it, you can get the expression for I2. So the current is going. What is the leaving polarity? So if you redraw it, it will be more clear for you to make you the things more better. This is a positive terminal, this negative terminal, and this is V2, and the current flowing is I2, and this value is RC into alpha I1. This is RC and this is V. So here I can write down I2 is equal to the voltage difference V2, and this is also difference is nothing but minus RC alpha I1, and this is positive and negative, somewhere it is leaving, minus V divided by RC. So only up to this point I am writing. Okay. So I'm not considering this. Why? Because if I consider both I1 plus I2 will be there. This branch I'm not writing. Only up to here I'm writing. And moreover, we have been short circuited this branch V2. So we can take this as 0. Already we have been short circuited this. Therefore, I2 is equal to minus alpha I1 minus V by RC. So therefore, we are going to have the alpha of I2 is alpha I1 minus V by RC totally divided by I1. So therefore what we are going to get is, this is minus alpha minus V by RC. This is 1 I 1 by 1, so this will come to 1 by I1. When you substitute here, this is minus alpha minus 1 by RC I1. The value of V already we have been solved. The value of V is I1 into 1 minus alpha RB RC divided by RB plus RC. So you will not have this value. Okay. So therefore this is the resultant value of H21. So successfully by short circuiting V2 equal to 0, we have been find the values of H11 as well as we have find the values of H22. Now when you come to the output port, now we are going to find out the remaining two parameters. Okay. So already here, so now we have to perform I1 is equal to 0. So what is I1? This I1 is 0, and we have to find out these two parameters. Okay, so what I'm going to do is I1 is 0, so we have an voltage and I1 is 0. So I1 is 0, then automatic resistor is there. So the drop created in this branch is V is equal to I1 into RA, but I1 is 0. Here this will act like an short circuit. Okay, and here you are going to get the branch. Therefore, the voltage at this point will be shifted to this point. This is V1. This is RB, and here we have RC, and you can see this source. So in this source, I1 is 0. If I1 is 0, this completely an short circuit. So this is completely an short circuit, and here we have the voltage of V2 and the current in this branch is I2, and this source is short circuited. Okay, so this is the resultant we are having. So now how to write down? So here we require the relationship for V2 and I2. Very simple. So how to write down I2? I2 is equal to, what is the voltage at this point is V2. So the voltage at this point is V2. This is the current I2. Therefore I2 is equal to V2. The current is flowing like this. So V2 minus 0 divided by, so the I2 current is flowing completely here. Okay, so V2 minus 0 divided by RB plus RC, and the same I2 current which flows here also will also flow here. Why? Because this branch is not there completely, this is not there. So here only we have V1. So I2 can also be written as, which is V1 minus 0 divided by RB. So now we require H22. So H22 is equal to, bring this V2 to the denominator. So I2 by V2 is equal to 1 by RB plus RC. Good. Next, V1 by V2. Okay. So how to get V1 by V2? So here H12 is equal to V1 by V2. So here what is the value of V2 in this expression? V2 is equal to I2 into RB plus RC. So the denominator is V1. What is the value of V1? So the value of V1 is I2 RB. I2 will get cancelled. The resultant value is RB divided by RB plus RC. So we have been very successful in finding out H22 and H12. So these are the resultant values. Okay. So you see the problem in overall look. It's very simple, but it takes some time to understand. So these are the our resultant values. H11, next one H12, this is H21, and this is H22. So this is how to find out. You see the problem from the starting onwards. So we, in order to get the answer, we want to find out, I will repeat the problem, we need to find out this voltage. So we find the voltage, and we have been performed output as short circuited, and we expressed the terms in terms of V1 by I1, and we have got V1 is an unknown variable that should not have I1 and V1, so we substituted, so all the parameters cancelled, we had got 1 1. Similarly, we need to find out I2 expression. Okay, so we have been find the expression of I2 and we substituted. So from here, this is very simple. Okay. So successfully for any kind of dependence load, slowly we have to analyze how to solve these kind of problems. I think this is very tough. It's not much easier to see the problem once or twice, which you can understand better. If you feel the content is useful, please like and please share with your friends. If you have any doubts, let me know in comment section. And if you're watching the channel for the first time, subscribe the channel. This is a free channel for the benefit of students and faculty. Yours obediently wrong. Thank you for watching. So just write down the given question and solve in your method and see that whether you get the same answers or not. We'll meet in the next video. Thank you for watching.